Okay, so the first thing we're supposed to do today is problems 8, 9, 10, 11, this opening for just kind of a warm-up for a recall of 10.2 information. So open those up and I'm going to give you some time to get that done. Go ahead, do problems 8, 9, 10, 11. Okay, so let's talk about these as we're going through. First thing is you guys need to know and be aware on how things are going to be going. Okay, at this point, you should be able to read this and know that this is a trapezoid and what a trapezoid looks like generally when you do it. Maybe if I can get it to be drawn. This is 20, this is 14. The height is the perpendicular length, which is 5 in this case. So trapezoid formula hopefully is recalled. B1 plus B2, make sure you put it in parentheses. H, 1/2, 20 and 14, 34. Times height, that's 17. 17 times 5 gives us 85 centimeters squared. Okay, now from here we shouldn't have to recall the picture totally for a trapezoid, but in this case I've got the same thing. I'm using the formula. I've got 1/2 base 1 plus base 2 times height. I got 1/2 of really 15 because that's what 8 plus 7 is times 5.2. I believe this comes out to be 39 inches squared as we get this done. Okay, are there any questions about it regarding this? These are pretty straightforward, basic. If you're not familiar with this, if you're copying it down from my board, change, because this is basic success to be at 70% for this test. Okay, basic. Now, when we're doing this other one, we're talking about diagonals, and the area with diagonals that are perpendicular, they talk about kite here. And a kite generally looks like this. I got two diagonals that are perpendicular to each other to give me 12 and 3. I'm not even, one's 12, the other one's 3. I guess you know which one's the 12. And this is 36, okay, divided by 2, which is 18 feet squared. Now in this last one here, as we go through, I've got still, the area is 1/2 diagonal 1 times diagonal 2. And we're talking about a rhombus. The rhombus is a shape, okay? All the sides are the same. It's kind of kite-esque. That's perpendicular, okay? But what's going on is I got diagonals yet again, and I'm going to go 1/2 of 6 times 9 gives me 27 yards squared. Okay, those I should have known right off the top of my head, no problem. If I didn't, you have some recursive reading to do. Just go over it and cover it, because I'm telling you, the test ain't gonna be pretty for you, okay? You got to make it pretty for you. I'm just telling you, these are the things on the test, and it's formulas. It's formula centric. You can have this list of formulas on your note card, know what they do, and be able to be super successful. But if you don't know how to use them, it doesn't matter how good your formula sheet is. Success is based on your understanding and knowledge on how to perform with the formulas together. Okay, so that's 10-2. Okay, that's our warm up for 10-2. Let's go get after 10-3. Basically what we're doing, we got an objective to find the area of regular polygons, okay? Now, regular polygons are polygons with all the sides the same, all the interior angles the same. And I'm recalling from theorem 6.1, polygon angle sum theorem, the sum of the measures of the interior angles of an n-gon, or a regular polygon, is n minus 2 times 180. Actually, it's not just a regular polygon, it's all polygons, with n as being the number of sides. Now, theorem 6.2 is polygon exterior angle sum theorem. It's talking about the total sum of all the exterior angles of a polygon are 360 all the time, no matter what the size. Okay, so if I want one solitary exterior angle of a regular polygon, it's 360 divided by n. This is all review from first semester, chapter 6. Now, something new today is an area of an equilateral triangle. Okay, this area of an equilateral triangle is the square of the side, and we're going to use that as x. I'm not going to represent that as s. Sometimes I go back to s. I'll talk about s squared being square, you know, a square squared, the sides of the square, but those s's, they look so much like 5s. It's a little hinky. So I'm using x as the length of my side. So what I'm trying to say is this. This is x, that's x, that's x. Okay, no problem, right? Because it's a equilateral triangle. I am going to show you where this formula comes from, this 1/4 x squared, the square root of 3, okay? And I want to be clear about something. Right now, there are second of 3 formulas we're going to be able to use to find the area of an equilateral triangle. And people kind of get frustrated. Like, well, what if I have that many choices? When do I know when to use what? When you're provided the right amount of information to use a formula. Okay, or you want to be a little bit more streamlined. This one's pretty streamlined. Once I know a side length, I just grab this one and I square it and divide by 4 times the square root of 3 and I'm done. Okay, but how in the world did we arrive at this? Remember 30, 60, 90 triangles. Half of a equilateral triangle gives me 2 30, 60, 90s. I'm just going to make sure that that's over so you guys can see. And the top one, this is 30. These are 30 degrees, these 2 angles, both 30 degrees. This is 90 and this is 60. So is this. Now, because of that, because I just split it in half, this is now x over 2 on this side, and this is x over 2 on that side. So now my altitude is determined by my 30, 60, 90 triangle pattern. Because it's the longer leg across from the 60, I multiply the short side, x divided by 2, by the square root of 3. So this side here, I'm going to get rid of some stuff just to make sure it's a little bit clearer. There. So that's 30. This side is x over 2 times the square root of 3, because that's where that length comes from. It's opposite the 60-degree angle. And people are like, oh, where does he make this stuff up? 30, 60, 90. This is 2x, this is x, this is x, the square root of 3. But remember, if I do halves, if I just take halves and I just talk about that, that's x over 2, and I just multiply it that way, the way I'm using the formula right now, okay? That's where I'm getting my numbers. It's stuff we did in Chapter 8, Section 2. Total have to recall. And I told you at the time, this is a pretty heavy-duty section. There are 15 questions on Chapter 8 on the final, okay? Just Chapter 8 alone. This information's extra beyond that. And it's still stuff we have to recall. But let's talk about what I have here. Remember, area of a triangle, you knew back in the day, is 1/2 base times height. Well, my base is x. That's the length of, so 1/2 x. My height is x divided by 2, the square root of 3. Well, check it out. If I get things together, or if I show it this way, I got 1/4 x squared, the square root of 3. That's where it comes from. I have just derived a formula we get to use as a shortcut. Completely, totally based on the fact that I use 30, 60, 90 triangles, because in an isosceles, an equilateral triangle, okay, I get to use that. Questions about the equilateral triangle that I got going on there. Now we have regular 1/2 base times height, or 1/4 x squared, the square root of 3 for an equilateral triangle area. Now, sliding on. I'm going to give you a hint on this, I guess. Well, let's get rid of that for a sec, and we'll get rid of this for a sec so you guys can see what's going on. I'm just going to use the formula we just derived. That's it. I'm off to the races. When we talk about the derivation of formulas, that was another explanation of it, but I just did it on the previous page. I just take my 5, I pop it in for x. That's it. That's all I'm doing. And now I evaluate. Now, when I'm doing evaluations, I want it exact. Okay, I can't have any decimals, and if I do, I make it a fraction. I get very familiar with the fraction key in my calculator, okay? And I just multiply by the square root of 3. So I got 25 times 1/4. Well, that happens to be, as I write it, 25 the square root of 3 over 4. This is considered exact. It's in lowest terms. I don't have any factors in common, okay? But if I wanted approximate, I put it in my calculator, 25 times the square root of 3 divided by 4, and I get 10.83 feet squared. Both are acceptable answers when I don't ask for any particular order, but make sure you have units on there. Dress up your numbers. You don't want them naked. It's embarrassing, okay? Now, your turn. Please use the formula. Go. Okay, it's all about formula. Using this one. Take the side length with this 8, pop it in. 64 divided by 4 is 16. So you got that 16 the square root of 3 feet squared is my exact answer. My approximate, 27.71. Okay, anytime you put an answer into the calculator and it's got decimal stuff and you round, that's an approximation. Okay, and how do I round? Always, unless told otherwise, to the 100th. Questions regarding these? Now, keep in mind, formula basics. Make sure you're familiar with it. Make sure you've written down how we use it, because it's at the time that you prep for the test, it's a reread of your notes, not a refigure. Your notes should be done completely in a way that you read it and go, oh, that's right, that's what I gotta use. I should put that in my note card. Okay, that should totally be in your note card as we go through that formula as we go through. Note card representation right there. Sliding on. Now, remember I talked about 1/2 base times height. Okay, I want you to see this too, because I'm not saying you must use this. I mean, there are times it'll open itself up that you're going to use 1/2 base times height. It'll be easier. Okay, how do I go about doing it? First, I got to remember that if I'm going to cut this in half, okay, it's a 30, 60, 90. Half of 8's 4. That's my short side. My longer side is 4 the square root of 3, which in this case is the height of my altitude, my height slash and or altitude of my equilateral triangle. Well, because that's my altitude for the square root of 3, I can totally go 1/2 base times height. My base being 8, the whole length, okay, and 4 the square root of 3 being my height. Now I can use 1/2 base times height. Could I have used 1/2 x squared the square root of 3? Heck yeah! But I wanted to make sure you knew that they're connected. Okay, I didn't want to just go, well, you see either this or this. It's either, depending on the information provided. Y'all had choices this morning in your closet of what to wear, and you chose what you chose. You had your reasons. Okay, we can choose what we choose if we have our reasons. Some are faster, some take a little longer, but they all work, provided you go through the process correctly. Now, I always get a kick out of students because they'll like do it and go, well, I did mine differently. That's okay for me to have a different answer. Nuh-uh, it's the area of a figure. Your way, my way, however we did it, should be the same. If it ain't, somebody made a mistake and we got to check and talk about it. Okay, so keep that in mind. Now, as we go through, I got 4 times 4 because, you know, half of 8, and I got 16 the square root of 3 as my exact answer. But 27.71 units squared as my estimated or approximate answer. Now, I want you guys to use the same method I just did. I want you to use 1/2 base times height. You must find the altitude of that triangle. But remember, when I find that altitude, I got to go x over 2, half that side length, and it's x over 2, the square root of 3, because this is a 30, this is 60, that's 90. This should be, excuse me, shouldn't be 2x, but shoot 2 times x over 2, which is just x. Okay, so use that pattern to help you in problem 4. Go. Remember, half of 10 is 5. Okay, so this is 5, this is 5, this is 5, the square root of 3. So we're off to the races. I got 10 times 5, the square root of 3, divided by 2, because half of 10 is 5. Okay, now after I get that, I got 5 times 5, which is 25, the square root of 3. Unit squared is my exact answer. And then I pop it in my calculator, got 43.30. Any clarifications? We doing okay? Now, we just worked through 2 ways to find the area of an equilateral triangle. Okay, one, just based on side alone, 1/4 x squared the square root of 3. The other, based on the idea of 30, 60, 90 triangles, finding the altitude and having a base, okay, and working it through. 1/2 base times height. Either way, it would work each time. Now, as we slide on, I want you to know a shortcut, that there are 6 equilateral triangles inside a regular hexagon. 6, count them, 6 equilateral triangles inside a regular hexagon, okay? I need you to be aware that only a hexagon has this type of relationship. And why? Why is it just a hexagon, Bloom? Well, let's talk about it. What is the central angle, remember 360 divided by 6 for a hexagon? What is that central angle? Yeah, you're okay with 60 degrees? Well, gosh, whiz bangarang, 60 degrees. Well, what's the interior angle of a hexagon? Excuse me, the central angle of a hexagon is 60. I meant to ask, what's the interior angle of an equilateral triangle? Just wanted 60. I wonder if there's a connection. Let's talk about this. So I break this down. Here, this is 60, so is that, so is that, so is that, so is that, so is that. Guess what? The exterior, well, the other angles, not the exterior, but the other angles, are also crazily 60. That's where my 6 come from. It's not like it's secret. It's not anything that Bloom just like makes up just for the heck of it to make you memorize. It's a fact, Jack. So let's get it done. Just remember, it's only a hexagon does this work for. And the reason why I'm showing it to you, because when you go through some stuff, it's easy to have a shortcut. Once you find the area of a equilateral triangle, if there is a hexagon with the same measurements, multiply that area by 6 and you have the area of that hexagon. Okay? 6 equilateral triangles inside here. So now I'm off to the races. Got my exact, which is 150 to the square root of 3, and I got my approximate, which is 259.8. So keep that in mind as we're going through. It's your turn. Do 6. Remember, practice. Show the equation. Show the numbers you plugged in. That way, when you actually reread your notes, you're actually rereading instead of refiguring. Reread your notes instead of refigure your notes. If you want to be better practice at this, cover up your solutions and do it again. Your tests and quizzes are made up from your notes and your assignments and your quizzes, your homework quizzes. Okay, just make sure you're aware of that. It's not a secret. And then we do a practice test. Okay, when I do that, I call it practice test because you're getting ready for the test. Those are the things I'm testing on. Again, the formula I'm using only works as a hexagon. Okay, if you're using this formula for any other shape other than a hexagon, we're hurting. Okay, you're doing it wrong. Side length is 8. I plug that in for x because that's what it represents. 8 squared is 64, divided by 4 is 16. 16 times 6, gosh, it gives me some funky number. It's like 96. The square root of 3 is my exact. Pop it in my calculator, and I can round to the 100th, and I'm done. Now, those are the basics of equilateral triangle, finding the equilateral triangle formula, 1/4 x squared the square root of 3, finding the area of an equilateral triangle using 1/2 base times height, using the idea of 30, 60, 90 triangles to find me the missing pieces, or I can just use the side, to help me using the equilateral triangle, and then finally hexagon using the equilateral triangle 6 times. Okay. Now we're going to talk about the diagramming of our radius of a regular polygon. The radius is the distance from the center to a vertex, and I put that in blue going out there. The apothem of a polygon, it sounds like I'm lisping, but we got it in red there. The apothem is the perpendicular distance from the center to the side of the polygon. Now, this perpendicular distance, because we are talking about regular polygons, this is the perpendicular bisector of the side of a polygon. Okay, it goes from the center to the midpoint of the side. It's called the apothem. Now, there's something called the radius, and I want to emphasize the radius, this blue. This blue, the radius coming through there, the radius itself is actually the radius, not only the polygon, but the circle that circumscribes that polygon. A circumscribing circle goes through a regular polygon, and all regular polygons, at the vertex. So we go through at the vertices as we go around, okay? And the big plus about this, the reason why they call it the radius of the polygon, it goes from the center to the vertex of the polygon and the circle. And even-sided figures, if I take the radius and double it, it's the distance across the polygon. Okay, it's kind of a fun thing. All right, so keep that in mind as we go through. But the next thing, central angle. Central angle measures an irregular polygon. Divide 360 by the number of sides of the polygon, 360 the number of sides. And in this one, I got a central angle of 360 divided by 6 is 60 degrees. And we kind of remembered that from, gosh, chapter 6, chapter 9, talking about central angle stuff. Okay, when we're talking about repetitive rotations of a figure, bring it back to itself. So it's nothing new. It's another way of looking at stuff. What's really cool about this semester, we review all the chapters. Every other chapter is almost reviewed by the next chapter. So make sure you're paying attention to these. And what I just did, it's all about vocabulary. So reread, reread, reread. Okay, let's talk about this next one. To find the measure of angle 1, it's 360 divided by 5. Why by 5? It's a 5-sided figure. It's called a pentagon. Okay, so I've got a pentagon, 5-sided figure. Consecutive radii are these blue dotted. Okay, so keep that in mind. It's 72. The green, 72 divided by 2, the green angle here, this one right here, angle 2, 36. I'm just taking my central angle, dividing it by 2. Okay, because they cut it in half. The apothem cuts that angle in half and goes to the midpoint. Okay, it's really cutting that isosceles triangle that's made, that's the central angle. Question? Okay. The last one, they want to go angle 3. Angle 2 and angle 3 are complementary. They add to 90 degrees. I got it right here. I could go 180 minus 72 if I wanted to talk about the relationship with the central angle and 180, because these would be the isosceles, base angles are the same, or I could just talk about the sides, but either way it's 54. Now it's your turn. I want you to do exactly the same figures. They're found the exact same way with an octagon, 8-sided figure. Remember, you must be familiar with triangle, 3-sided, quadrilateral, 4-sided, pentagon, 5-sided, hexagon, 6-sided, heptagon, 7-sided, octagon, 8-sided, nonagon, 9-sided, decagon, 10-sided, hendecagon, 11-sided, dodecagon is 12-sided. You've got to know from 3 to 12 the formal names of the number of sides. Okay, outside of that, they'll say 42 gon, okay? 42, a dash, and a gon, G-O-N. Now, if you want to know those names, you want to review them, you can check your Chapter 6 notes from last semester, or polygons.com. Crazy, but they're all there, along with the name of every other type figure that you could imagine, okay? But I only want 3 through 12 because ACT, SAT, MCA all require that, okay? Go ahead and finish up. You guys got 8. Find them in the exact same way. 360 divided by 8. That value divided by 2. Subtract that from 90 and you got it made. $45 degrees should have been angle 1. 45 divided by 2, 22.5. After you got there, subtract from 90, 67.5. How you doing? Is that all right? First 3 questions of your homework today, just covered. Now, sliding on. We have yet one more formula for finding area. Now, I showed you shortcuts for a square, side squared, and we're going to go back to them. We also, for a square, we can use 1/2 diagonal 1 times diagonal 2, okay, for a square. For a triangle, we got those other 2, 1/2 base times height, okay. We have 1/4 x squared, the square root of 3, depending on the situation, the information provided. You can use either one of those, or you can use this one. Okay, for a hexagon, we showed if you got the side length, you can use 6 equilateral triangles to find the area of a hexagon. This formula I'm about to show you will work with all polygons, but there are some like the ones I just listed, I would use another information unless they gave me something else. I wouldn't find a bunch of stuff if I knew a formula I could just do it quickly for. But here it is. The area of polygon, regular polygon, is half the product of the apothem, that's the distance from the center to the midpoint of one side. Remember, the sides are all the same. And the perimeter, P, where A is equal to 1/2 AP, apothem times perimeter. Okay. Now, remember, perimeter is the number of sides, N, okay, times that side length, S. S is side length. So if you multiply the number of times a side happens, you have perimeter. Okay, so 1/2 AP could become 1/2 ANS. Okay, so you might see it as this. Whether I do it as 1/2 AP or 1/2 ANS, they are the same. P is N times S. So you've got to know that. Okay, that's part of this. If two figures are congruent, then their areas are equal. And that's like one of those DA formulas that someone came up with. Hey, if they're congruent, the area is the same. You don't have to do nothing. Okay. Now, let's talk about what we just did and review it, because it'll be fun. I know in this one, 12.3 is the apothem. I know in this one, it's a 10-sided figure because it's decagon. And I know in this one that S is 8 inches. Okay, so if I go perimeter, I know perimeter is 80. And I probably should put some units on that. That's 80 inches because that's just single. My area, apothem is 12.3. I just gave you two values of a formula we were just told about. That formula, 1/2 AP, pop it all in and use your calculator and do the walk and hit enter. Go. You got to know what things are, the apothem, the number of sides, how to find them from 3 to 12, from triangle, quadrilateral, etc., all the way up to hendecagon and decagon, dodecagon. You got to know how to use your calculator. You got to recognize what information is important that they give you, what information is not important that they give you. That is the difference between you guys doing it as sophomores and people doing this for the first time as 7th graders. Because this is in the 7th grade text, that 1/2 ANS, 1/2 AP, okay, depending on the book series. But they don't do the sine, cosine, tangent stuff that we're going to do in section 10.4. They do this stuff, and you got to be able to know when to use a formula, okay? Are you okay with 492? Remember, no naked numbers. Make sure you dress them up with units, okay? Now, I've got exact and approximate. Over here, I've got exact, 492, approximate 498. They're the same. Pretty cool. It's your turn. I want to be clear about what I'm doing here. I'm going to use 1/2 AP because that's my theorem, my theme here. And remember, whether I do it this way or by 2, I got this as 18. So this cuts in 9 and 9, that's half of 18. 9 the square root of 3 is the apothem from the midpoint of that side to the center. So this is 9 the square root of 3. Okay, because all I'm doing is working with my 30, 60, 90 triangle. I have to know how to do that physically. Okay, get rid of this from my last class. Okay, so we got that one. So now I know the apothem, it's 9 the square root of 3. I know the perimeter, it's 18 times 6. I pop stuff in. I pop it into my calculator. How do I get the exact? I multiply everything except the square root of 3. If it doesn't come out really nice, I hit my fraction keys, my decimal diffraction buttons, and I know how to work those. If you need assistance, I'm more than happy to show you how to use your calculator to help you with fractions. And then I slap on the square root of 3 in the numerator spot, okay? And that's how we get that done. So I have 486 the square root of 3 as an exact. Now, I multiply out that square root of 3 and I get my approximate. Whenever I multiply an irrational value towards a bunch of other numbers, when I go for save as fraction or make it a fraction, it won't do it. because it's an irrational number. It can't be represented as a fraction. Questions up through 10 so far. We doing okay? It's your turn. Turn the page, do problem 11. Let's debrief. Make sure you got to recognize words when you read them. That's the thing that makes this class difficult. I expect vocabulary knowledge. You just don't know math. You got to know vocabulary too. So what is the area of a regular pentagon, five-sided figure, with 8 centimeter apothem and 11.6 centimeter side? Well, I know that this red mark is 8 centimeters right here. This is 8 centimeters right there, okay? Now, I also know because they told me that each side, my blue mark, is 11.6 centimeters, okay? Well, I've got to be able to find perimeter, and I know apothem now. It's that red mark that's 8 centimeters. My perimeter should be 11.6 times 5. Should be 58 in itself. Yeah, 58, okay, as we go through. So I've got that. So now I just use my formulas. Okay, and this was all because of the previous information, reading and the basic formula, and knowing where everything's located. If I don't know after today's notes, unless I ask questions, I won't know for tomorrow's notes. And I'm telling you, the next time we do this, it's going to be higher tech. I'm using sine, cosine, and tangent to find pieces we're missing. This is just the basic stuff, plugging stuff in. Okay. So I got 1/2 8 times 58. I pop that in my calculator, and hopefully you're coming out with 232 centimeters squared. Okay, you and your calculator are one, right? As we go through. And if I'm asking an exact or simplest radical form, 232 centimeters squared is the answer. Don't be looking for anything else. If it turns out nice, it turned out nice. Any questions on 11? Now, here's the thing. In 12A, B, C, and D, we have squares, and I'm not going to be shy about this. These all can be used for 1/2 ANS. But why would I do it? Okay, so let's talk about this. First, the distance from the center to the midpoint of a side is 5, and in an even valued shape, an even side is value, that distance the same as up. What's 5 plus 5? This whole thing is 10. That happens to be the length of a side. And in a square, it's the length of all the sides. So not only do I have a side length, I have area, which is 10 times 10, which is 100, and I have perimeter, which is 10 times 4, which is 40. But I'm asked here to find area, so I can take S squared, 10 times 10, 100. I am not going to have you do anything else. And some people, well, how else would you do it, Bloom? Well, here's the deal. This is the apothem, right? So I could totally use that fact that that's the apothem. So that's 10. But remember, this is a 45-45 triangle, and those two sides are congruent. So if one's 5 and this is 5, this also is 5 because that is also a 45-45 triangle. So this is 10 right there. So that's how I'd find 10 by 10. And I could go for that way. Or, once again, using S squared. Or I could recognize that I had A is equal to 1/2, my apothem, which in that case was 5, times my side length, which is 10, and my perimeter times 4, remember, 40. What's 20 times 5? It's still 100 inches squared. I don't care which way. It's a couple ways I can look at it. But I'm going to tell you, I've been working with squares and squaring the side length. It is so much faster to get to that side length squared. I'm going to use that most of the time. If I'm giving you a radius, and I will do that in C, I'm going to use that A equals 1/2 diagonal 1 times diagonal 2 because it's faster. But we'll get to that in a second. It's your turn. Do B the way we did A. The first one, the first way. I don't want you to know the others or worry about the others because in all honesty, if I'm on a test, I do it A times side squared is equal to side squared because it's faster. 8 doubled, 16, so I got 16 squared. 256, done. Not doing anything fancy. A square is a rhombus, okay? Has all the properties of rhombus because the diagonals are perpendicular. A square is a rectangle, has all the properties of rectangle, says diagonals are the same. So the information I'm about to do and tell you that 10 for the radius is 10 up there for that radius, so I got a diagonal of 20. What's 20 times 20? Divide by 2. 200, done. Don't make it any worse. And I walked you through the wrong one there. I would totally have done it this way. This is the way I prefer. And that's 20 times 20. That's where I get my 200. But I also showed you doing the exact same stuff I just did using that 45, 45, 90. If I have a leg of a 45, 45, 90, the hypotenuse is the leg times the square root of 2. So 10 to the square root of 2 times 10 to the square root of 2, which is my side, is 200 as well. Okay, I don't care which one you use. They both work. I like the diagonal one, it's faster. I don't have to think as much. I just got to double it. You guys go, do D. Number 5 times 2 is 10. 10 times 10 is 100. Divide by 2 should be 50. Should be 50 for D's answer. And if I do it this way, this is 5 to the square root of 2, side squared, 5 to the square root of 2. Hey, it's 50. But if I do it like this, if I go area is equal to 1/2, because my diagonal is 10, and my other diagonal is 10, that's 100 divided by 2, which is also 50. So my answer should be 50, however way I do it. Okay, if I have any other values, I've got to make sure I change that. Questions about my squares? We're doing okay? All right. Now keep in mind, today's notes is all about formulas and all about finding areas of stuff that are pretty easy. We're talking about equilateral triangles, squares, and hexagons. Okay? Being efficient with our time and use of formulas. I don't know where that came from. But now, check it out on this one. I have an apothem provided. It's pretty quick. I don't have to do a lot. This value right here is that apothem is actually 1.5 to the square root of 3. That's my apothem. That value is 1.5 the square root of 3. Now, I got my apothem. Gosh, if I'm going to use that apothem thing, I've got my perimeter. Because there's 6 sides, and each side is 3. My perimeter should be 18, as I'm going on here. And now, I got 1/2 ANS. By the way, N times S is the same as P. Number of sides times the side length is perimeter. You should be able to go back and forth whichever way I give it to you, but you got to know how to get perimeter quick. Go ahead, pop those in. After you do that, you have the choice in problem 14. You can do it by 6 times 1/4 x squared to the square root of 3, or the 1/2 ANS method. Your choice. Go ahead. Do 13 and 14 at this time. Remember, it's all about you practicing and then asking questions about your practice. It's like looking at video, okay? It's the best way to correct mistakes that you may be making. Hopefully you're not, but if you are, best way to correct some mistakes. On the first one, I just pop in my values. Pop in my calculator. I'm done, 23.38. How you doing? Okay, once I know stuff, it's all calculator function. I have to know what an apothem is, the distance from the center to the midpoint of a side. I have to know what a radius is, the distance from the center to the vertex, where 2 sides come together. Okay, I have to know how those measurements are related. And once I know those, oh, things are golden, because I'm just plugging stuff into an equation and I got it. Okay, now I couldn't even tell you, I think I did the apothem method on this one. Okay, they tell us that this is 16, so this is 8 and that's 8. So that means that's 8 to the square root of 3. Okay, and remember, the side split in 2 Half the side in a hexagon is the short side of my 30, 60, 90 triangle that I'm working with. And just as a review, I'm going to put it in the same orientation I'm working with. This is 8, this is 8 the square root of 3, and this is supposed to be 16, and it will be as I connect those together. Those are 16 because of the same. So now I got that going on, and I plop things in. Where did I get 96? Okay, when I'm doing this, my perimeter is equal to the number of sides times my side length. Well, the number of sides 6, my side length is 16. That's where 96 came from. Okay, now I'm just finishing out my problem. I do the exact answer and I do my approximate. Exact are with that square root there. Okay, so it's all about the formula. It's all about apothem, radius, knowing how to get it, the 30, 60, 90 triangle, using the recall of 45, 45, 90 triangle. If you're not sure about those, boy, please come in and get help. The more experienced you are with something, the easier it becomes because you've done it before. I strongly recommend to go over the things that you're having difficulty with and do them again. You have the right answer. Practice. The more often you practice at something, the more efficient you become. The more often you practice at something, the easier it is. Okay? The first few times might be clunky, klutzy feeling even. But the next couple times you start recognizing things and you become more in tune about what you don't get, and you can ask more direct, pointed questions, and we're able to have a conversation that's very short and quick, okay, as we go through. Now, I've got, 8 problems left. Okay, I do these so you can recall a couple things, and we got some shortcut items. Okay, I don't do them because I want to just beat you down. All right, but today's a great day for it because we can take a little bit of a mental break and correct our 10-2 assignment, and then we have our 10-2 homework quiz, and then we're off to the quiz, not the homework quiz, but the assignment today. And that assignment today took people less than 15, 20 minutes. Okay, so everybody was done with everything before they left the class. Keep in mind, as we're going today, I am reviewing things from previous chapters we've actually used. You guys remember centroid? 2/3 of the distance from the vertex to the centroid point. It's the balance point of any shape, considering the shape has equal thickness in a triangle. Okay, it's from chapter 5 first semester. Okay, there are points of concurrency that we review it with. Here's the deal. 2/3. This is 2 parts. This is 1 part. What's half of 4? 2. That's my 1 part. I got 6 as my total 2 plus 4. Okay, that's 6. Right? No problem. Now, one of the things that's helpful when I do this is I know that this is my short side. That's 30. This is my longer side. Now I should change that color. I mean, that's what I'm going to do. We're going to do that in a different way. This is my short side, or my hypotenuse, I should say. This is actually 4 as well, because the distance from this to the vertices should be the same. But now, as I go through, this is my longer leg, 2 to the square root of 3. This also is 2 to the square root of 3. That means my side length is 4 to the square root of 3. Okay, I now have 2 choices to find the area of this equilateral triangle. I can use 1/2 base times height, where the base is 4 to the square root of 3, the height is 6. I could use 1/4 x squared to the square root of 3, where x, the side length, is 4 to the square root of 3. It's up to you. I decided to do it this way, okay, because I wanted to bring that back in front of you, okay, for no other reason, okay. Now, could I have constructed this triangle another way to find other pieces of information? Sure. I could have looked at this triangle this way. If this is 4, this is 2, this is 2 to the square root of 3, this is also 2 to the square root of 3 because that's the midpoint. Still 4 to the square root of 3. It's another way of looking at how I could get that other piece of information, but I have apothem, which is 2, side length, this is 4 to the square root of 3, and I could go be off to the races for 1/2 A and Fs as well. So any one of the 3, it's your choice, okay? when you do it. But whatever of the three you choose, the answer is always the same, 20.8. If it's not, oops, okay? Oops. We got to check. Is fat fingeritis on our calculator, or we just got the wrong value somehow, okay? Your turn, do B. Your turn, do B. And it's all about the last final answer. Make sure you do this on your own cleanly, okay? You've got to do this. You've got to do this. Okay, so keep in mind, 2/3 is 2. Half of 2 is 1. So I got the full height is 3. Okay? Full height is 3 as I go through this. This is 1. So if that's 1, this is 2. This is the square root of 3. This also is the square root of 3. So I've got 2 the square root of 3 as my length of a side. That's what I'm going to use. Okay? It's dangerous when you do this because instead of 4 times 3, people get 2 times 3 and they get just half the size of what they're supposed to because it's a calculator move. You should have, for an answer, 5.2, not like, it's going to be 2.6 if you made a mistake. Be careful. Be careful. Know how your calculator communicates. Be careful. Last one. Got a side measure. Use 6 times 1/4 x squared, the square root of 3. Only for a hexagon. I say that and I still have people try it for every one. It only works for hexagons. Go for it. Hexagon shortcut. Get her done. Pop it in and get her going. Physical manipulation of the equation. Know what to do. That's your job. Remember, this is algebra review as soon as we get to the equation because you are just plopping in numbers and recalling what you do with square roots. But the vocabulary property portion is knowing what to put in, what the equation is, and making sure you're successful. X is 3. Pop it in. We've got that going. It becomes 54, the square root of 3 over 4. That's the exact answer, by the way. Well, I've got to reduce a little bit. Maybe I lied. 27, the square root of 3 over 2. This is exact. Pop it in my calculator, round to the nearest tenth. That's what they asked me to do, and that's rounded to the nearest tenth. Okay. So what I want you to do is recognize we have 5 left, and I want you to work on them over the next 5 minutes. It should take about a minute per. And remember that if it's from the vertex to the center, it's 2 shares. If it's from the center to the midpoint of the side, it's 1 share. So you got to double it to find the whole thing. Okay, so give it a try, see how you do. Use others as resources, but I expect everybody to get it done in the next 5 minutes. Go. Okay, keep in mind, as we do these, we are doing these for the first time. The reason why you're given an assignment so you can figure out how to go about a problem on your own, apply the correct method, and do it on your own and come back and check to see where we're at. Because the first time when you do something on your own, it's tougher. Okay, if you changed oil with your dad 100 million times, or your mom, whatever that is, and then you do it for your first time, you're still like, what was that next step again? You start doubting yourself, okay, because replacing that engine is a big deal. All right, so just make sure as you go on your first time, make sure you keep practicing that. So when we do this, there's a couple things I can do. I know that this was 2 parts to that 1 part, so this is 10 and the whole thing is 15. I can use that as my height. Okay, I've got this, my hypotenuse, going down, and this is going to be 5 to the square root of 3, my longer side. This is also 5 to the square root of 3. This whole side is 10 to the square root of 3. I now can use base times height divided by 2. I can use 1/4 x squared to the square root of 3, or I can use 1/2 ANS. I don't care which one of the 3 you use. You've got to know which piece of information you provided and where things go. But right now we have all of it, and we have that choice. I decided to go 1/2 base times height. Okay, I got my base 10 to the square root of 3. I got a height 15. Okay, boom, golden. I got 75 the square root of 3 as I go through, and I pop it in my calculator because this is considered the, excuse me, hate that when I do that. That's considered the exact answer. This is the approximate, 129.9. Okay, and I rounded to the 10th. Same idea in E. Remember, centroid, that's what I'm using. This is 14. This is 21. Using the 1/2 base times height, 14 to the square root of 3 times 21. Totally getting her done, 254.6. Did you use another one? It should be the same answer. If it's not, oops, we've got to talk. Because either I did it or you did it. Fat fingeritis abounds. It's possible. Okay. My last one, once again, I've got a hexagon. This one, keep in mind, this is 4, this is 4, this whole side length's 8. So I'm going to go for that 1/2 ANS or AP because I can quickly find that looking at my apothem. Okay, especially when it's a square root of 3 like that. Boom, it's fast. Okay, so now my perimeter, keep in mind, is 8 times 6, which is 48. So 4 to the square root of 3 is my apothem, and I'm getting her done. Okay, 166.3. I always get people going, oh, these take so long. Then you don't know the shortcuts. You're doing it the long way. Okay, start thinking about the shortcuts as we're going, because that's all this is. 10.3 is all about us knowing the shortcuts. We should be able to implement these when given the opportunity and choice. Okay, now I got 2 problems left. There's squares with diagonals. And remember, squares that have diagonals in a square, they're rhombuses. That means their diagonals meet at right angles. Squares are also rectangles. So that means the diagonals are the same. So if I give you one diagonal, you really have both. So I've got, in this case, this is 20. Okay. Well, gosh, I hope I did the diagonal one. Good. That's 20 squared, 200, and that's it. Now, I also have, bless you, 10 to the square root of 2, and I could do it this way, and it'd still be 200. I don't care which one you do. It's your choice. Make sure you do the second one if you haven't done it. Should be 128 looking at it. Okay, 16 times 16 is 256 divided by 2 gives us 128. Okay, or I could have done it the other way. Either one. I know today's notes were longer than usual, but we also have 55 minutes left, I think. Yeah, roughly. Okay, so hopefully everything's going well. If you've got questions, make sure you come in quick and often, but we're going to correct 10.2 next.